Hello everyone and welcome to iExam B, where we help you to prepare 50% faster. So continuing with the IBPS SO IT revision series day 5, let us today solve some MCQs based on sorting algorithms. The first question is, what is the time complexity of bubble sort in the best case when array is already sorted? So if the array is already sorted, then bubble sort algorithm will have a time complexity of big O n. So the answer is C, of the order big O of n. So in this next question, you have to predict the output of the following code. You are given an array of elements and n is the length of the array. Then you are using nested for loops and the logic of a particular sorting algorithm is implemented here. After the nested for loop, you have to print what would be array of 0 and array of -1. So here, if you look at the logic of the code, then you would find that consecutive elements are compared and they are interchanged, something what the bubble sort does. So once the entire logic is completed, then the array would be sorted. Array of 0 indicates the first element and array of -1 indicates the last element of the sorted array. So the option of B, 1190 would be the correct option because 11 is the smallest element of the array and 90 is the largest element of the given array. In this next question, which sorting algorithm is most efficient for sorting a nearly sorted array? The answer to this question is C, insertion sort. So if you have a nearly sorted array, insertion sort would be the best algorithm to implement to sort the array. Next you have, what is the time complexity of merge sort in all cases? And the answer to this question is of the order n log n. So the D option is the correct option here. Now consider quicksort using the Lomuto partition scheme with the last element as pivot. For the given array which is already sorted in the ascending order, what is the time complexity of quicksort on this input and why? So the time complexity of quicksort on this input would be of the order n square because a sorted array causes maximally unbalanced partitions. In this next question, which sorting algorithm is not stable in its default implementation? The answer to this question is C, quicksort. In this question, you are asked which sorting algorithm is best for linked list. So if you have a linked list of elements, the best sorting algorithm would be merge sort. In the next question, it is asking counting sort is not suitable when, and you are given the option range is small, input is integers, data is bounded, and range of input is very large. So counting sort will not be suitable when you have a large input array. So the correct option here is range of input is very large, option D. Now let us look at this question. During a merge sort on the given array, we are splitting each subarray at its floor midpoint. How many total element comparisons occur across all merge steps? So here the answer is D13. The left half would be 38, 27 and 43. So if you split that up, it would be 38 and 27 and 43. Merging 27 and 43 requires one comparison and merging 38 with 27 and 43 requires two comparisons. So the left subtotal becomes 3. In the right half, we would split as 3, 9 and 82, 10. Merging 3 and 9 requires one comparison, and merging 82 and 10 requires one comparison. Merging 3 and 9 with 10 and 82 requires two comparisons where left gets exhausted and then 82 is appended. So the right subtotal becomes 4. In the final merge, we would have 6 comparisons, as you see. So the total number of comparisons would be 3 plus 4 plus 6, which is equal to 13. In this question, you are given an array which is 5, 4, 3, 2 and 1. When insertion sort is applied in ascending order, you have to tell how many element shifts are performed. Here, the answer is C10. For a reverse sorted array, insertion sort performs the maximum number of shifts. So the number of shifts would be 1 plus 2 plus 3 plus 4, which is equal to 10. So with that, we come to the end of this video. I hope you were able to solve all these questions on sorting algorithms. Have a wonderful learning experience with iExamB, and thank you for watching.